So in this problem, when we read the question, we look at what's given to me and what's needed or what's unknown, right? So do I know my Q? I'm just gonna run through the formula and make a list of all the variables that I do and don't know. So in this question, is heat given? So to find Q, the unit you look for is capital J, joules, because that's what heat is measured in. So is J given? Are joules given in the problem? Yes. How many? 64.0 joules right here. Okay, that's my heat. Then is my mass given? How much is it? Correct, 15 grams. Then is my C. What do we remember what C stands for? C stands for specific heat. Is the specific heat given? Because if you read the problem, what does it say? Determine the specific heat, right? So that is your unknown variable. And in this problem, how many temperatures are given? 2. 22 Celsius and 33 Celsius. Now, how do we find delta T? Delta T is always final temperature minus initial temperature. And so between these two temperatures, which one would you consider my final temperature? 33, because it says from 22 to 33. Okay? One thing I will point out at this moment is do not automatically assume the higher number to be your final. Okay? You always have to pay attention to how the question is worded. Whatever the from temperature is, that is your initial temperature. What is your to temperature is, that is your final temperature. Okay? So in this case, 33 minus 22, which comes out to 11 degrees Celsius. So now we check. I have all the variables I need. I just plug them into the equation. So 64.0 equals, because that's what my Q is, 15.0, which is my mass, times C. I'm going to leave that as C because that's the unknown. Times, what is my delta T? 11. And so now to solve for C, I will have to move the other two numbers to the other side, right? So 15 and 11 have to go on the opposite side. So you do 64 divided by 15 times 11. Oops. Okay, so 64 divided by 15 times 11. So you have to put these in parentheses. And that gives me 0.38. I have to have 3 6 big, so 0.388. Okay, so 0.388 joules per gram degree Celsius, because that is the unit of specific heat, C. Okay, so that is your answer. In this problem, The question says a 50-gram sample of water at 100 Celsius, okay, so this is boiling hot water, was placed in an insulated cup. So what I'm going to do is I'm just going to like visually like represent this problem. So we're going to assume that this is my insulated cup. What is the significance of having an insulated cup? To keeps the heat in, right? To insulate something means to prevent the temperature from changing, right? So this is my insulated cup. What do we have inside of this insulated cup? Water. How much? 50 grams of water. So we'll say that this is 50.0 grams of water, and this is at 100 degrees Celsius. So this is boiling hot water. Now, what do you do to this water? You took a 25.3 grams of zinc metal, which was at 25 degrees Celsius, right? And because zinc is a metal, and metals are denser than water, so this block of zinc sank to the bottom. So we'll label this as 25.3 grams of zinc, and this is at 25 Celsius. The temperature of water dropped to 96.68 degrees Celsius. What is the specific heat of zinc? Now, in this problem, you have two different materials, right? You have water, which is at a different temperature, and you have zinc, which is also at a different temperature. So my first question to you is, it says the temperature of the water dropped. Why do we think it dropped? Because the zinc was cold, right? And we have learned already that heat will always flow from a high point to a low point. In this particular example, the high point was the water. The low point was the zinc metal. And so heat went from the hot water to the cold metal. So if the temperature of water dropped to 96.68 degrees Celsius, what do you think happened to the temperature of zinc? Say that again. It went up. What do you think it went up to? Okay, let me put this question in a slightly. In questions like these, what we do is we make two little columns. Okay, one is for the first substance, the other one is for the other substance. Okay, over here we write down the same variables: Q, M, C, and delta T. Okay. Now, in this problem, anywhere, do you see what is the, is there like a joule number given in this problem? Do you see the unit capital J anywhere? No. which means, do I know my Q? I do not. So I put a question mark for both of them because I don't know. What about my mass? Do I know the mass of water and do I know the mass of zinc? Yes. What is the mass of water? 50 grams. So 50.0 grams over here. What is the mass of zinc? Correct. 25.3 grams. Now, do I know the specific heat of water? Yes. Remember, we always know the specific heat of water. That will never be given in problems. You just have to know it. And that value is always 4.184. Okay? That number doesn't change. The C value for water is always 4.184. Do we know the specific heat of zinc? No, because it says what is the specific heat of zinc, right? So I'll put a question mark over there. Now, to find delta T, what do we need? Final and initial. As far as water goes, what was the final temperature of water? 96.68. That's what we ended up with. So that is my final temperature. So 96.68 minus, what was my initial temperature? 100. What kind of number is this going to give you? A negative number, because 96 minus 100, right? So negative 3.32 Celsius. What about zinc? Do I know the initial and final temperature of zinc? Yes. What was the initial temperature of zinc? 25. What did it ended up being? 96.68. Because the final temperature of zinc and water is the same because they're in the same environment, right? The zinc is in the water. So whatever the temperature of water, the same temperature of zinc. So 96.68 minus, what was my initial temperature? 25 Celsius. Okay, so if I do 96.68 minus 25, that gives me 71.68. Now here's the thing. The question is asking me, what is the specific heat of zinc? Which is this right here. Can I solve an equation with two unknowns? No, you cannot solve an equation with two unknowns. The question is specifically asking me to find the specific heat, which means somehow I'm going to have to come up with the value of Q. Okay? So before that, let's look at water. Is it possible for us to find the value of Q for water? Yes, because it's only one unknown, right? And we know that as far as water goes, we know Q would be equal to mc delta T, right? So you just multiply this, this, and this. So 50 grams times 4.184 times negative 3.32. Okay, so 50 times 4.184 times negative 3.32, which gives me a negative answer, which makes sense, right? Because we had a negative number to begin with. So negative 694.54. We can only have 3 sig figs. So we will round this to negative 695. negative 695 joules. Okay, now there is a significance to this negative value. The reason why this is negative is because heat was lost. How do we know heat was lost? Heat was lost because the water got colder or hotter? Colder. How can the temperature of something drop if it loses heat, right? So this negative value shows 695 joules of heat was lost by water. Okay? Now, if this much heat was lost by water, who was it gained by? The zinc metal, right? And we know that has to be the case because this is an insulated cup. So whatever heat that was lost by water is gained by the metal block. So now, turns out we know what the value of this Q is. But the only thing is, it has to be now positive. So on the side, let's note down that a negative Q means heat lost, and a positive Q means, okay, a positive Q means heat gain. Very good. Okay. So over here, did zinc lose or gain? Did zinc lose or gain? Gain. Did water lose or gain? Lose. So now we know that this answer for water is negative 695. Okay, so we'll put this in parentheses because we found it. It wasn't given to us. And we know that this is positive 695. Now, is it possible for us to find C? Yes, because now we only have one unknown variable. So I will write 695 equals 25.3 times C times 71.68, which gives me C is equal to, all I'm doing is rearranging this equation. Okay, so C would be equal to 695 divided by 25.3 times 71.68. $695 divided by parentheses 25.3 times, which gives me 0.383 joules per gram degree Celsius. Okay, so these are the two types of problems that we're going to come across. There will be some practice problems that we will do on Monday over this. So make sure that you keep this handy. And for the rest of the day, you have a concept map that you need to do. So go ahead and get that done. Just take a screenshot and turn that in. Okay.